In this video, I'm going to go through what a slicing program does and some of the basic settings that you need to consider when you're 3D printing a file for the printer itself. This program is Ultimaker Cura, and this is a completely free program that you can download. I use this at home all the time with my 3D printer, and it is compatible with a whole range of 3D printers. So if you go to the Ultimaker, or you just search up Ultimaker Cura, you can download it. I've currently got it set up for my printer, but if you wanted to add a different printer or when you first get it, if you go to non-networked printers, there is a huge list of brands and things like that. You just find the brand that you've got, drop down, find the printer that you want, and you can set that up. At school, because we have the Zortrax printers, we'll use the Zortrax Z Suite software because it doesn't work with this program. It only works with its own software. So I will make a second video specifically for the Zortrax and how that looks, but a lot of the features are very, very similar. So there's always those options to move around. In this case, right click is my rotate tool, so I can rotate around an image and see what it looks like. Let me load something first and I'll show you what we can do with it when we go to print. This is a towel hook from The Witcher that I want to 3D print. And generally with this software, once you load it, it should automatically orientate it in the best angle. So you can see it's got a flat base to fix to a wall or something like that. So it makes sense that that is the ground level and we print up. If I was to rotate it, which I can, and I'll show you how to do that shortly, it doesn't really make a lot of sense to print a file like this, partly because there's very little actually touching the bed of the 3D printer, and it's going to need lots and lots of support, which will take longer. It won't look as good because the support affects the surfaces that you print on. So I want to print flat. The other thing to consider is a 3D printer cannot print over empty space. So from here, it'll print layer by layer. So it prints this layer at a very, very thin height, then it jumps up and it prints this layer. So it'll slowly work its way out every single layer here. In some cases, if you've got smooth enough curves like this, it can probably do that without affecting the print, without it collapsing, because if it's only jumping out maybe a fraction of a millimeter every single layer, it's enough that it can print. So in this program, if I go to preview and Zortrax does a similar thing, it'll show me what it's actually going to print. So here I can see that it wants to print a support under the chin piece to support that because it doesn't believe that it can print that. And as you would expect, the teeth here are basically hanging over nothing. That's a very sharp angle. So when it gets to this layer, I'm then expecting it just to print over empty space. So it's going to make up this support in the middle, which is basically a very thin layer of 3D printing filament that I can just snap off later once the model is printed. And if I need to, I can sort of sand it and clean it up a bit. And it's doing the same thing with the ears. It wants to print a little bit of support under the bottom part of the ear because it thinks the angle's quite sharp. But from this point on, it can handle it and do it itself. So that's what it'll actually print. This is what I see. This is what the printer will produce. In terms of settings, there's a few things we need to consider, which again, this is going to look different depending on what printer you're using. And I'll show you the Zortrax specifically. But we almost always have a layer height adjustment. And layer height is basically how much detail do you want on the print. For things like curves in particular, if you're printing a box and it's perfectly square, you generally want the thickest layer height that you can get because it's going to be faster. The main difference is when you look up close, you might see individual lines on the 3D printing file for a large height. And the other one is if you print a curve, it's going to look very rough because the height is quite stepped. So it's like zooming in on a set of stairs. You'll see each of those little jumps. So for this, because I've got lots of curves and a bit of detail, I'd probably want something closer to 0.2. That's quite a good resolution for how I've got this printer set up. I can still print at 0.3, which is just that little bit quicker, but I'll lose some of that detail. And just to give you a comparison of what kind of effect that has in terms of my time. If I was to print this as it is at 0.2 mils per height, it's going to take almost 3 hours, 50 minutes. If I change that to 0.3, it drops back to 3 hours. So I've almost lost an entire hour just off that 1 mil of height. The next thing to look at is the infill setting. And this is really just how solid do you want the object. So in this case, I've got it set at 20%, but if I ran it at 100%, it wouldn't print any gaps or holes within this object. It would print it 100% solid. And that's going to have a fairly significant effect on the time. So if I print 100% solid, it's now going to take almost 6 hours. If I drop this down to 10%, it's now only going to take 2 hours and 50 minutes. So there are a lot of different settings you can tweak with. In terms of your infill, you really just need to consider what is the purpose of this thing that you're printing and how strong does it need to be. If it's something like this coat hook, it needs a little bit of strength in it because I'm going to hang keys off it, but it's not super heavy. So I've always printed this at like 20%. If it was purely ornamental, it's just a model, it's going to sit on a shelf, it's not like a hinge for something, it's not going to be locked, people aren't going to mess with it, you could probably run anything from 10 to 20% quite happily. Whereas if it's something that has a functional purpose, like a door latch, a lock, a switch, something like that, you would probably want to make it stronger, and you can up the infill. The pattern is what it feels like. What is the pattern that it actually creates in the middle? And I'll show you an example of this. So these are some different infill patterns. By default, the hex is the most common. So it either prints a grid or a hex pattern like a honeycomb. And here you can see the different infill. So this is a 0 infill. So I print this object with 0 infill, it prints it completely hollow. This is probably something like maybe a 5% or less infill, and you can see that there is very little space inside the object that is filled with a solid thing. So it would be quite soft. And we gradually get to a larger infill, and we're getting larger and larger. This would probably be more like a 60-70%, getting higher again, very close to 100, and then this would be 100% infill. So it's a completely solid object. And as you can see, there are other patterns depending on the software. Some of them will create these weird spirals, some stars, almost like a puzzle effect. In this one, it's just creating squares. Doesn't really make any difference. Generally, the best setting is just to either go with the honeycomb or the grid pattern. And again, the infill percentage just depends on partly how quick do you want it to print and how strong does the thing need to be. So that's infill. Most of the other settings, generally you won't mess with. You can change things like the speed that you print, how thick the edging parts are. You can really tweak with it. But generally for the basics, the only thing I would recommend changing is your layer height and your infill percentages. You can alter the support, and depending on the program and the printer, once you get a hang of what the thing can actually do, you can sometimes change this. Like you saw in my example, when I sliced this, it's going to print under the chin and the ears, which for my printer, for example, or from this model, I've actually printed that without this support. I know that it can do that. So I would change this to, say, 70%, or sorry, 70 degrees. And that basically means whenever the angle that it's trying to print is greater than 70 degrees, put a support. Now you can see it's printing much less. It's only this little piece here that it's going to struggle with. The teeth we always knew were going to be a problem, but I've lost a lot of it. I don't have the support here that I had, and I've got much, much less around the ears as well. So that's going to save me a bit of time as well. The less I have to print, the faster it's going to be. So that is layer height, infill density. Remember, I've got cubic. In this case, I've got lots of different options for my printer, and support angles, which I would generally just leave those as standard. So that's generally the slicing software. From here, once I've got everything sorted that I want to do, I can either save it to disk, or in some cases, if the computer is plugged into the 3D printer like my setup at home, it'll give me an option of just print to the printer directly from the computer. But for the Zortrax, it uses a little SD card. I just click save to disk, I save it somewhere, and then I put that into the Zortrax machine and I tell it to print, and it'll do all the things for me. So this is the slicing software. Slicing software takes your Fusion file or whatever it is that you've got. It converts it into a language that the 3D printer knows how to read, so it knows what sequence to do everything in, where to put support and if to put support, and then from that point the printer can do it. So it's the middleman of your model.